Hey friends, welcome back to Analyze with Casey, where we take intimidating tech topics and make them feel a whole lot more human. So, this episode is inspired by a subscriber who messaged me and said, I'm self taught in SQL, so take this with a grain of salt. But maybe you could do something on indexes, deadlocks, and archiving. Oh my. First of all, yes, thank you. This is gold. Because I remember being exactly there. You finally get a query to work and you feel like a wizard. And then someone says, well, is that indexed? Or watch out for deadlocks. And suddenly it feels like the yellow brick road just fell out from under your feet. Today we're breaking it down. What's slowing your queries down? What indexing really does? What a deadlock even is? And why you probably need to archive all of your old data before it buries you alive. Let's start with indexes. Think of a database table like a giant book. If I told you to find every patient with the last name Sanchez and you had to read every page line by line, that's what a full table scan does. Now imagine that book has a table of contents that tells you exactly which page has what. That's what an index does. It helps your database find things faster. So when you write a query like this, select star from patients where last name equals Sanchez, if there's an index on the last name column, boom, your query's fast. If not, the database has to check every row one by one. That can take forever on a big table. But here's the catch. Indexes are not magic. They're not free. Every time you insert, update, or delete a record, that index has to be updated too. It's like someone constantly restoring a deck of cards while you're trying to play a game. So yes, indexes speed up searches, but they can slow down writes. That's why you don't want to index every column. Here's the rule of thumb. If you're reading from the table a lot, especially with where conditions or joins, index those columns. If you're constantly inserting or updating data, be picky. Too many indexes can slow everything down. Here's a quick tip. Indexing foreign keys is almost always a good idea. Same with columns used in joins. Let's talk about deadlocks. They sound scary, and sometimes they are, but really, a deadlock is just what happens when two queries are trying to grab resources and they're both waiting for the other to let go. Imagine two people in a hallway. One steps left, the other steps left. They step right, the other steps right. They're stuck. Here's what this looks like in a SQL. Query A locks table 1, then tries to access table 2. At the same time, query B locks table 2 and then tries to access table 1. Both are waiting on each other forever. The database goes, nope, and kills one of them. Usually, this shows up as an error. Transaction process ID was deadlocked on resources. So, what can you do? Here are a few best practices. First, always access your tables in the same order. If every process grabs table A before table B, you avoid circular waiting. 2, keep your transaction short. Open it, do your thing, commit it. Don't leave a transaction open while your app waits on a user or some other service. 3, avoid unnecessary locks. Don't use select for update unless you actually need to lock those rows. And lastly, log your errors. If you're getting deadlocks and don't know where or why, add logging to capture failed transaction details. Okay, now for a topic that doesn't get enough love, archiving. Let me guess, you've got one giant table with every transaction or every patient from the past 10 years. If so, that table's not just heavy, it's bloated. Archiving is about separating what you use all the time from what you barely ever need, but still want to keep. It's like cleaning off your kitchen counter. You don't throw your tax returns away, You just don't need them next to the coffee pot. In databases, that usually means moving older records into an archive table or partitioning your table by date or exporting it to a data warehouse or blob storage if it's really cold. Here's an example archive query. Insert into patients underscore archive. Select star from patients where it was created older than 2 years. Delete patients that are older than 2 years. This pulls old data out of the main table and into a long-term storage spot. The result? Faster queries, less index maintenance, more manageable backups. And yes, if you're in healthcare or finance or anything compliance heavy, you still keep the data. You just move it to a place that doesn't slow your production system down. All right, let's recap. Indexes. Use them like seasoning, just enough to make things better. Deadlocks. Avoid them by locking things in the same order and keeping transactions short. Archiving. Don't let old data slow your system down. Clean house. If you're self-taught in SQL and these topics made you sweat a little, don't worry, you're not alone, and you're doing better than you think. Performance isn't about knowing everything, it's about knowing what questions to ask when things get weird. Here's what I'd love. If one of these topics still confuses you or you want me to go deeper, drop it in the comments. Tell me, do you want a full episode on indexing strategy? A breakdown of real-world deadlock logs? A tutorial on partitioning and archiving? I built these videos based on what you need, not just what looks flashy. And if you like this one, hit subscribe. We've got more SQL, more healthcare tech, and more plain language walkthroughs on the way. Oh, and if you want a PDF cheat sheet with index tips, deadlock rules, and archiving steps, just comment SQL Kit and I'll send it to you when it's ready. Thanks for watching. Go make your queries faster, and I'll see you in the next one.